Hello everyone, welcome to today's webinar, AWS CloudHSM. Before we get started, I have a few housekeeping items. On the right side of your screen, you will see a Q&A window. Please use this to submit your questions for our presenter and moderators at any time, and we'll address them while they come in. At the conclusion of today's presentation, there will be several poll questions preceding the Q&A. Please take a minute to provide us with your feedback when you see these poll questions appear on your screen. We are recording today's session, and in the next few days, we'll send you a follow-up email with the links to the deck and the recording. And again, welcome to today's webinar, AWS CloudHSM. Our presenter today is Avni Ramia, here with AWS Cryptography. Avni, welcome. The floor is now yours.
Thank you. I'm excited to talk about AWS CloudHSM today. This service helps you secure and keep control of your own encryption keys in the AWS cloud. So AWS has two solutions to securely control and use keys. We have CloudHSM and Key Management Service, or KMS. AWS CloudHSM provides you with a dedicated FIPS-validated HSM under your exclusive control within your VPC. KMS is a multi-tenant managed service for your keys. KMS lets you enforce who can use your keys, when they can get rotated, and who can manage them. It is also integrated with several AWS services. Both services offer a high level of security for your cryptographic keys. Today's talk is focused on CloudHSM. All communication with your HSM is done over a channel that is encrypted end-to-end, so it is not visible externally to us. You alone control the users on your HSM and their access policies, and you alone control user access to keys and cryptographic functions. In other words, you keep control over the access management to your encryption keys, and those keys stay protected within secure and compliant hardware security modules. These HSMs are available within the AWS cloud, so you benefit from high performance, low latency. Again, these are managed, but they are your HSMs. We launched the second generation of CloudHSM earlier this year. The new service provides fully managed HSMs in the AWS cloud, making it easier to use and also making it more affordable. The first generation of this service was based on SafeNet Luna HSMs and is now called CloudHSM Classic. CloudHSM Classic remains available unchanged to current users of CloudHSM Classic. We do have an FAQ for users of CloudHSM Classic at the link showing on your screen. Today's webinar, however, is focused on features and use cases for the new service, which we launched in August 2017. Customers use CloudHSM for strong security of keys. They use it for high-performance cryptographic acceleration or a combination of the two. CloudHSM supports a wide range of cryptographic algorithms, operations, and key lengths. You can use CloudHSM to support a variety of use cases and applications. Customers most often use CloudHSM for applications like TLS or SSL offload, PKI infrastructure and certificate authorities, database encryption, document signing, and digital rights management, or DRM. Let's take a quick look at how some of these applications work. So in the online CA example, you can integrate CloudHSM into your application using our industry standard libraries, either PKCS11 or JCE. You can also use CMG on Windows for integration, for example, with Microsoft Active Directory. In this application, you would create and store private keys safely, again, under your control on the HSM. And you would then use this to sign digital certificates that are used to identify a person or an organization. In the case of database encryption, TDE or transparent data encryption is used to encrypt the data stored in an Oracle database before saving it to disk. Encryption is managed using a master encryption key. So you would use AWS CloudHSM to store the TDE master encryption key. The cryptographic officer can allow different cryptographic users or database users to use that key, and you can provide more than one HSM within the cluster so you can scale your workload as necessary. The last example we'll look at really quickly today is SSL and TLS offload. This is a popular use case for CloudHSM. You can generate and store your web server's private key in CloudHSM for added security. And you also benefit from increased performance by offloading the computationally intensive processing, specifically the signing operation, from your web servers to HSMs. You can expand and shrink your cluster as website traffic fluctuates. Load balancing is handled for you automatically by the service. So this is a quick look at the performance that you can expect from your HSM instances within CloudHSM. In the SSL offload case we just looked at, for example, you can expect each HSM to provide about 1,000 transactions per second. Symmetric operations such as AES encryption or decryption essentially occur at wire speed. You can store up to 3,500 keys, and it doesn't matter whether these are symmetric or asymmetric keys. You can store 3,500 keys per HSM. And you can scale clusters up, cluster being a group of HSMs that work together as a high availability group. You can scale clusters up to 32 HSMs. Scaling the cluster doesn't increase key capacity. Every HSM in the cluster is essentially a clone of every other HSM in the cluster, and we'll look at that in some detail shortly. What the cluster does is it provides increased throughput. So you can achieve, for example, up to 32,000 RSA sign and verify operations from a single cluster in one VPC. It's also important to note that when your application is not in active use, you can scale your cluster down all the way to 0 HSMs. We do provide backups. These backups are taken automatically and stored securely. And when you create a new HSM, you can create one from backup, essentially pick up where you left off. So you can scale clusters up and down. We will look at that in some detail as well. The important thing here is to note that you can, in fact, scale a cluster all the way down to 0. So what are some of the benefits of using hardware security modules? HSMs provide control. They provide secure access for you to create and enforce users and policies. You can set up with CloudHSM fine-grained access management policies for up to 1,024 unique users on your HSMs. In some sense, the notion of users in CloudHSM is similar to partitions that you may see with other HSMs. Each user, however, has a flexible view of which keys they create and they can share. So a user can create keys as the creator, they are the owner of that key, and the owner of the key can share that key with up to 8 other users. Those users can use the key for cryptographic operations, but they cannot manage the key, meaning that they cannot delete or in turn share that key with other users. So what this does is it gives you a flexible space within your HSM. Those 3,500 keys that you can store per HSM can be managed across a number of user accounts. Again, AWS has no access to your encryption keys. We also don't have any control over the users that you are creating or the password rotation policies, for example, that you may have in place, or functions such as MFN or quorum authentication or two-factor authentication that you may require for your users. So in fact, if you were to forget a cryptographic owner password, we in fact can't recover that for you either. The HSMs are entirely under your control. So CloudHSM provides fully managed HSMs in the cloud, and we provide this in the full sense of the notion of fully managed. So these are smart load balancing clusters with automatic failover. As you add HSMs to your cluster or remove HSMs from your cluster, the clients are automatically updated and they will automatically load balance across available HSMs for you. If for any reason an HSM were to fail, we would automatically replace that HSM for you as well, and the remaining HSMs in the cluster would automatically connect to the new healthy HSM. So you have automated high availability, and you can scale your clusters up and down with a single API call. You do pay as you go with no upfront costs, so you only pay for an HSM while it is active by the hour. And that allows you to flexibly scale your clusters up and down as workload fluctuates. So if you have a sudden upsurge of traffic to your website, or if you have a large batch of certificates that you need to process, you can scale your cluster up to multiple HSMs. Once the workload subsides, you can start to remove HSMs from your cluster. And because you only pay as you go, you're not really paying an instantiation cost per HSM. You have flexibility to scale up and down without any financial penalty. We do automate the backups of HSMs. These backups are secure and can only be restored to AWS CloudHSM hardware. The backups include a complete snapshot of each HSM. So this includes the keys as well as the users and the policies. That way, each new HSM is a perfect clone of the HSMs that it is created from. And we'll look at backups again in a bit more detail later on in the presentation. So CloudHSM also provides monitoring and logging. We provide CloudWatch metrics that can give you insight into the health of your cluster, into the health of the individual HSMs, how much memory is being utilized, the session counts, and the CPU utilization. So what you're seeing in the graph at the bottom of this slide is a rotating workload that is cycling through cryptographic operations. You can see that the CPU percentage is cycling accordingly. You can, in fact, have custom alarms. So when your CPU utilization goes past a certain threshold, for example, you could create an alarm that automatically adds an HSM to your cluster. Similarly, if you see the CPU active percent fall below a certain level, you can have an alarm that removes an HSM from your cluster. That way, you make sure that you're always equipped to handle the workload that your cluster is handling, but at the same time, you are not overpaying for spare capacity that you may not actually need. You can also see that there is an HSM unhealthy alarm. This is the blue line that's all the way at the bottom. The continuous blue line at a level of 0 is actually telling you two things. One, that you're continuously communicating with the HSM because you have healthy data points coming back. And secondly, that it is not unhealthy, that it is in a good state. You can also see your ongoing session counts concurrently. That's another way you can keep track of how your cluster is being used. Now, we don't actually have visibility, as we mentioned, into the communication that you have with your HSM that occurs over an encrypted, an end-to-end encrypted channel. What you do see in CloudTrail is a history of your calls to our services API. So when you describe clusters, for example, or create or delete HSMs, or when you log into the service, all of those you can see in CloudTrail logs. What we're going to do next is deep dive into how the zero configuration high availability with AWS CloudHSM actually works. This is the ability for you, again, to add and remove HSMs, have the synchronization taken care of for you, and have the load balancing taken care of for you. We'll start with the concept of a cluster. The cluster is more or less the fundamental construct in CloudHSM. Every HSM that you create, even if it's the only one you have, is created as part of a cluster. A cluster is essentially a group of equivalent HSMs. So they're identical in terms of users, policies, passwords, and keys. And as such, you can interchange any one of them to execute a cryptographic operation for your application. The cluster can have between 0 and 32 HSMs. Again, you can spin the cluster down all the way down to 0 if you don't have an active workload. You can, in fact, delete the cluster altogether, and the backups will still be retained. So if you wanted to recreate a cluster from a backup, you could do that as well. You may, in fact, also recreate a cluster from backup if you wanted to change the configuration of a cluster. So for example, if you wanted to change the VPCs or the subnets that were being used in the cluster, you would do it this way. You would delete the cluster and then restore it from backup. The clients automatically load balance across all the HSMs available within the cluster. We also have failovers, so if for some reason a given HSM is not accessible, the client will notice that and redistribute load among the available HSMs. The cluster should be implemented across availability zones, particularly if you're looking at a high availability application. So when your cluster is actively in use for a workload, we do recommend that you have at least 2 HSMs in the cluster and that those be distributed across different AZs. As you add additional HSMs into the cluster, you should continue to distribute them across AZs 2 or 3 to a region. We do currently require clusters to be within a single region. This is done for performance and for latency as well as for data sovereignty reasons. We do not support cross-region replication today. However, you can import and export keys out of HSMs and into other HSMs under your control. This depends on how you have configured your clusters and HSMs, how you have configured your keys, and how you decide your cryptographic material can be used. But you absolutely, from a service perspective, it is supported that you can move keys from one HSM to another HSM and use them across regions that way. So there are 4 steps to get from creating a cluster initially to having an active HSM. You really have to only do this once for every new cluster that you create. From that point on, as we talked about, you can restore a cluster from a backup file. So when you create a cluster, you set up an environment for your HSM instance. You configure the VPC, you configure the subnets, you can tag it with a resource name, and once it's set up, it's ready for the first HSM to be created. When you create the first HSM, there are a couple of things you will want to do. The first is to verify that your HSM is in fact an authentic HSM in the AWS cloud. So we provide 2 certificates. One demonstrates that it is authentic FIPS validated hardware. The second demonstrates that this hardware is installed in the AWS cloud. Once you've verified those, then you can go ahead and initialize the cluster, which means that you sign the cluster certificate with your credentials. This, in fact, makes it yours. So from that point on, whenever you establish a connection to the HSM will send you the certificate that you signed, and it will demonstrate ownership of the corresponding private key. That way you always know that you're talking to your HSM. So once you've made the HSM yours, the next step then is to activate the cluster. This is the only step that you have to do through the CLI alone. So for steps 1, 2, and 3, creating a cluster, verifying the HSM, initializing it, you can use either our console or the CLI. Activating has to be done through the CLI. What you will do is log into the HSM, establish that end-to-end encrypted channel. Then you will change the default password for the PRECO, or the preliminary cryptographic officer. That then makes you a cryptographic officer of the HSM. From that point, you can use the HSM however you choose. So you can create additional CO accounts, you can set up MFN or quorum requirements, you can create cryptographic users, you can set and change their own passwords, you can create and delete keys, you can run cryptographic operations. Essentially, that HSM is now yours to use as you wish. So this is what an activated cluster will look like in the context of the console. As you can see, we have a cluster with the ID that's showing at the very top. Its state is active, and it is housed in your VPC. The HSM that you see at the very bottom was the first HSM created into the cluster that you can see is active, meaning that you have logged in, you have set the passwords, it's all ready to go, it's yours. You can see that there's a second HSM whose creation is currently in progress. Now, if you wanted to add a third HSM to the cluster, you would simply click the blue button to the left that says Create HSM, and a new HSM creation will automatically go into progress. That HSM will be a clone of the first HSM that you see at the bottom. Again, same cryptographic material, same user, same passwords. If you decided that you wanted to shrink your cluster for any reason, you could choose any one of the active HSMs by selecting the radio button, and then you would choose delete HSM. So it's a single API call or a single button click, and you can expand and shrink your cluster very, very conveniently. You can see that you can also see all the backups that are taken. That's the second tab from the left top. And you can also see the tag certificates and monitoring data associated directly from your console. What we're going to do now is take a slightly deeper look at how clustering actually works, specifically the zero configuration clustering, meaning that when you click a button to add HSM or when you call the command to add HSM from the CLI, what's really happening under the hood. So you can see the way that the current cluster is set up. You have an application that is talking to HSMs through ENIs or elastic network interfaces. These are created for you automatically by the service. The application has a configuration file that again is automatically updated that informs it which ENIs connecting to which HSMs are available in the cluster. And again, the load balancing is automatically managed there. On the server side, the individual instances, HSM instances within your cluster, talk to each other as well, and they stay in active communication with each other. So if you were to create a key on one HSM, for instance, it would automatically be transferred to the other HSM instance as well, and that's how they stay in sync. When you go to expand a cluster, the first thing that will happen is a backup of that HSM will be taken. This, if you recall, includes the cryptographic material as well as the users and policies. So it is a perfect snapshot and a complete snapshot of everything that's contained on the HSM. The backup is secure. It is protected by keys that are built into the HSM during manufacturing, as well as an Amazon-specific key, as well as an ephemeral key that's created just for the purposes of the backup. This is then stored securely on S3. It is, again, protected with KMS. And the backup is taken in such a way that it can only be restored to authentic HSM hardware in the AWS cloud. So the backup is taken, and then what happens is the new HSM instance is created that again is attached to its own ENI, and the backup is restored to that HSM. So through that restoration, you now have an HSM that is a perfect clone of the other two HSMs already in the cluster. The HSM configuration is now updated, so each of the HSMs in the cluster now are talking to each other. That updated configuration is then pushed from the existing HSMs back to the clients that they are talking to. What happens now is the application becomes aware that there's a third HSM in the cluster, and it knows how to reach this HSM. And now you have a fully functional application with the expanded cluster. The load balancing automatically moves across all three HSMs now. And if any one of these were to go unhealthy, you would replace, the service will automatically replace it with another HSM, again, using a very similar process. You would have a backup, you would replace the HSM, the backup would be restored, and the new HSM ID would be communicated across the cluster and back to the app. Similarly, if you needed to expand the cluster, you would do that same HSM process that we went through. If you were to delete an HSM, you would simply have one of the HSMs go away and the updated configuration would be pushed back the same way. I did want to take a minute to talk about high availability best practices. When you have a production workload working with CloudHSM, you do want to make sure, as we talked about, that you have at least two HSMs and that they are distributed across availability zones. Your client application, we similarly expect, would be available across multiple availability zones in its own right. And each one of those instances would talk to HSMs across all the AZs. And that's how you would get a high availability configuration. So in summary, let's go through some of the benefits. We've been through the applications of each of these. I do want to summarize them one more time, provide them all in one place. So the new CloudHSM is pay as you go. It is based per hour, depending on which HSMs you actually have in active use. And again, there are no upfront costs for provisioning the HSM. So you are free to start and stop your HSMs on demand. You can spin your cluster down to 0 when a workload is not active. You can simply restore for backup when needed. But more importantly, it is a one-click cluster expansion. The synchronization is managed for you. Failover and load balancing is managed for you. We also have improved security. So these are FIPS 142 level 3 validated hardware. The HSMs also support MFN, which is quorum, and two-factor authentication. The 2FA actually works using off-the-shelf USB tokens, so it's easier to implement and easier to manage than it's been. The HSMs are fully managed within CloudHSM. So we looked at the automated provisioning. We also take care of any patching and firmware upgrades or OS upgrades that need to be done. So the entire fleet is managed by AWS. The backups are taken automatically and remain available for use for you, whether we're using them to expand or shrink clusters or to implement synchronization, or if you want to use an existing backup to create a new cluster altogether. And high availability, as we went through in some detail, is automated as well. The development environment is built on open standards. So we have PKCS 11 and JCE SDKs. We do have CNG coming shortly for Windows. And to the extent that you permit it, you can export keys to most commercially available HSMs. So there's no worry of being locked in, for example. The service is easier to use. Not only do we have a CLI, we also have the point-and-click console. So specifically for management functions, or rather particularly for management functions, it is much, much easier to use and administer. And you have automated high availability. So new clients are automatically reconfigured as the cluster configuration changes. Any new HSM in the cluster is automatically cloned, as we saw. And if for any reason there were to be a hardware failure, the replacement of the HSM is automated as well. We have CloudHSM available across 11 regions today. So these are all the regions where CloudHSM Classic was available, with the exception of GovCloud, which is coming shortly. We have been able to implement price cuts relative to CloudHSM Classic, so the per hour fee, although it does vary by region, is lower than what you've seen in the past. And again, there are no upfront costs to use AWS CloudHSM. So we're excited to bring this service to you. It does considerably simplify the management, provides flexible and industry standard development environments, is suitable for a number of different applications. And we look forward to continuing to improve the service and add features as we go forward. If you have any questions, we will be glad to take them now.
Great, thanks for your time and a great presentation. I'd also like to thank the moderators for answering any questions that came in. We're going to leave the room open for a few more minutes and continue answering questions through the Q&A pod. Please take a quick minute to provide us with some feedback in the polls you are seeing now on your screen. Also, we are recording today's session. We'll send you a follow-up email in several days with the links to the deck and the recording. Thank you.